In this video, we're going to learn how to find volume using cross sections. So what that means is we have this three-dimensional shape here. We're trying to find the volume of it. And we're going to break it up into a bunch of little pieces here. So there'd be one piece, here's another piece, here's another piece, and so on. We're going to find the area of each one of these pieces, or really what we're going to do is we're going to find a formula, a function, that tells us what the area is at different points. Then by integrating that, we get to add up all those little areas, and that will give us the volume of the whole shape. Now you see each of these little areas is a triangle, in fact a right triangle. So finding the area won't be too bad, 1/2 base times height, but we need to actually figure out what those are. And as I said, we need to have a formula that can tell us the area for any particular point. So we're going to go ahead and suppose that we've gone out, say, x along the x-axis here, and we need to have our base and our height of this triangle. So if I try to take that piece out of the picture here, if I can, we have our base, our height, and we know that it's currently x units away from the end of our shape. It's called tetrahedron, by the way. Right, it's got 4 sides, each of one of them is a triangle. So we need to find a way to have the base and height in terms of x. Well, if I want to look at the base here, in order to find a formula for that, I'm going to look at this triangle on the bottom here. So let me try to draw that. And then the base I'm looking for is going to be on here in our triangle. And we know that we've traveled along x units from the long edge of the triangle here. Now, in our picture, we see that the green triangle has a length of 3 on that side. So this whole side here is 3. We also see, based on this, that this side is 2, which means that if the whole side is 3 and that part's x, that means this little piece here is 3 minus x, and this purple triangle is similar to the green triangle, and so that means I can say base over 3 minus x, so that side over that side is equal to the same for the big triangle, 2 over 3. And so solving for the base then, it's going to be 2/3 3 minus x. So that formula tells us how long the base is going to be at any given random point. 3 minus x here, of our cross-sectional area. Now we're going to need to do the same thing to get the height here. And to do that, we are going to go ahead and look at this triangle here in the back. And I'll draw that over here. And again, we know we're looking for this h right here. And we know that the distance up there is x. We know the total length is 3, so that means this part is 3 minus x again. And then we know the height of this one is 6 at the far end. So setting up an equation for that would give me h over 3 minus x is 6 over, the total length is 3. So this one's going to give me h is 6 over 3 is 2 times 3 minus x. Putting that together, that means the area, really the cross-section area at any particular x, we can write this as a function a of x, is 1/2 base times height, because it's a right triangle, The height was 2 times 3 minus x. And if you go ahead and simplify this, one of the 2's cancel, and you're going to get 2/3 3 minus x squared. Now, in order to go ahead and find the volume here, we are going to integrate the cross-sectional area. And we know we're starting with x is 0 on one side of the shape, x is 3 on the other side. The cross-sectional area is this thing here. Now, we can either multiply that out and integrate it term by term, or we can go ahead and try to do like a u sub integral. Since that's not the focus of what we're doing right here, I'm going to skip the work on that just to get the answer here. So we know the 3 minus x is going to go to 3 minus x now to the 3rd power over 3. And then there's going to be a negative 1 there because of the negative x inside. But again, like I said, feel free to take the time to do the work to get that answer. I'm just skipping because we're focusing on the new technique, not the integral technique. And let's see here, we're going to get 2/9. Now if you plug in 3 into that, it's going to be 0. Right, 3 minus 3 is 0. And then if you plug in 0 into that, it would be 3 minus 0 is 3 cubed. So 3 cubed over 9 is going to be 3 times 2 is 6. So we get the formula, the volume here is 6. And you can check that by comparing it to the formula for the volume of a tetrahedron. You'll see the same answer. Now this was a bit messy, and in general it can work out and it can be messy, any given problem here. However, we are mainly looking at this right now because it's going to let us come up with a formula for volume when you're rotating something. So that'll be in the later videos here. This one's just to get up the idea of how you can do a cross-sectional area and add them up to get the total volume.